we're going to we're going to focus on trying to find my probability distribution, okay, as a table. Okay, we're going to do that by considering our probability function, okay, which is what's given here. Okay, so let's just take a look at this question right now. So we're going to have to find the probability distribution for x as a table, okay, which is here, of a binomial probability function, which is given by this function here. Okay, so before I write down all the distributions here, let's consider my function, okay, because that's where we're going to get our probabilities from. Okay, so if we take a look at this equation, okay, well, this function, we're going to have 4 combination x, okay, and 0.4 and 0.6, okay, and 0.4 represents the probability of one outcome, and 0.6 represents the probability of my other outcome. Okay, and these two probabilities add up to give me 1, which tells me, oh, this is a binomial. Okay, so this is how we lay it out as a binomial, and the 4 combination x, okay, is represented by, I want you to think about the 4 as the number of trials, okay, or the number of outcomes or the number of trials, and x is the number of, say, the number of successes, for example. Okay, so that's how we're going to think about it. Okay, well then, if I want to write out my probability distribution table, okay, then I'm going to have to think of all the different outcomes I can get, okay, because x is the number of outcomes, and then once we write the number of outcomes, we're going to find out the number of the different probabilities that each outcome gets. Okay, so in 4 trials, okay, if I have a success and a failure rate, okay, one or the other, out of 4 trials, I can either get these outcomes here. Okay, so I can either get no successes, 1 success, 2, 3, or 4 successes here. Okay, which gives me a total of 5 outcomes, okay, out of 4 trials. Okay, so we're going to find the probability of each of these outcomes. Okay, is what we're going to figure out. Okay, and we're going to use this function to do that. So, the first thing I'm going to do is find the probability when my outcome is 0. Okay, which means 4 combination 0, and I'm just going to replace all my x's just with zeros. Okay, so 0.4 to the power of 0 and 0.6 to the power of 4 minus 0. Okay, so I want you to put that into a calculator, okay, and I want you to write down the probability into the table like this. Okay, so that's the probability of my outcome of having no successes. Okay, so what about having 1 success? Okay, then let's just replace all my x's with 1s, okay, and insert it into my probability function. Okay, so put it into there. Okay, then my probability in that case is 0.3 blah blah blah, so I want you to put it into the table, okay, and do it for each of these other outcomes. Okay, so we're going to put x equals to 2, okay, outcome of having 2 successes, okay, and calculate it, and let's put that into our table. Okay, once we keep doing that, that's how we complete our probability distribution table. Okay, so x equals to 3, okay, so put all the x equals to 3, and this will be my probability. Okay, and finally, for x equals to 4, which is the same as having 4 successes and 0 failures, then this is my probability. Okay, and one thing to also note is, out of all these outcomes, and these are all the individual probabilities, they should all add up to give me a total of 1. Okay, so that's what it is. Okay, so what we've been working on is finding my probability distribution table from a binomial probability function.